Computer organization. This is my personal notes for computer organization and architecture. Btech, CSE or Aiml or ECE. Second year, third sem. Makaut. This is under Makaut for specifically under Makaut students. Classification of computer system. There are three types that are used in a computer system, that is hardware, software and human resource. Hardware, this is also classified that is memory, CPU, input or output. In software, system or application. Hardware is physical device attached with the computer. Memory stores program and data. LU is the main processing unit, performs arithmetic and other data tasks specified by the control unit. In register, we store data temporarily. CU supervises the flow of information between various unit. Input transfer information into memory. Output transfer information into memory. Software consists of the instruction and data that the computer manipulates to perform various tasks. Soft is the program collection of pros used to solve a particular application-oriented program. Example, Makaut database. System software. It is a program used to manage the entire system to help in executing various applications. Example, operating system, compiler or device. Human resource is a manpower or skilled person, the orientation on computer. This is the von Neumann architecture. This is very important for this theme. Program and data can be stored in the same memory. The computer executes the program in sequence as directed by the instruction by the program. A program can modify itself when the computer executes the program. It is a program consists of input-output driver. When a program needs an input or output operations, it called BIOS. Operating system. It is a collection of programs which acts as the interface between the computer user and the computer hardware. Compiler is a system program which converts high-level language to machine language and consisting of instruction of binary numbers. This is the register, number of bits required for each and every register, and the name of the register and the functions. Instruction code. One address instruction, that is, here our function given is x is equal to a plus b into c plus d. So first you have to load c, and the comment in the comment section you have to write that AC, that means the accumulator. It contains the memory address of C. Add D. That means now in accumulator AC plus MD. Before adding D, in accumulator there was an element, that is C. Now add D. So C plus D is now in accumulator. Now store T. Memory address 3 is now stored in accumulator. Now load A. Now memory address of A is stored in accumulator and add B. So now in accumulator A and B are added. Mult T. That means the operation you have done before, that is C plus D, that was stored in the T variable, is now multiplied with the current accumulator value, that is A plus B, and then store X. That means the ultimate result is now stored in X value. Like this, the second example will also you have to consider. Now zero address or stack based instructions. Fetch, decode, execute cycle. This is the flow chart, basic flow chart of fetch, decode, execute cycle. Addressing mode. This is very important. There are total 10 types of addressing modes in computer architecture. First is implicit or implied addressing mode. Second is immediate addressing mode. Then direct addressing mode. Then indirect addressing mode. Then register addressing mode. Then register indirect addressing mode. Auto increment or decrement addressing mode. Index addressing mode. Base register, then relative addressing mode. The different ways in which the location of an operand is specified in an instruction are referred to as an addressing mode. Addressing mode specifies the location of the data. The advantage of having different addressing mode is to give programming flexibility to the programmers with respect to the number of instruction and execution time. Now, what is implied or implicit addressing mode? Operands are defined implicitly, or you can say operands are hidden. Like example, immediate addressing mode. The operand described explicitly here. Direct or absolute addressing mode. In this mode, instruction of operands contain the memory address of the operands. I am saying the important terms and conditions for your exams, but to know the detail you have to watch our others videos, or you can comment down. Register direct addressing mode. Auto increment or auto decrement. This is a special case of register indirect addressing mode. After accessing the operand, the content is automatically increment or decremented. You don't have to know very deeply about each and every topic. Go through this and remember these topics. Signed magnitude representation. To represent the value plus 15, you have to write down the binary numbers of 15, or you can say binary representation of 15, and then find out the 2's complement of that particular number to get the minus 15. that is signed magnitude representation. The binary number 11101 represent in equivalent decimal number of in signed first and second complement method. Here you can see our given binary number is -13 because it is said that it is in signed form. Fixed point representation. Represent -7.5 to the basis 10. That means this is a decimal number using 8-bit representation with 4 bits as int and 4-bit fractions using 2's complement representation. First of all, you have to find out the 7.5 in binary number. First, write down 7 in binary number and then multiply 2 with 0.5. You will get 1.0. That is the number of fraction 5, 0.5. That is the binary number of fraction 0.5. Floating point representation. This is the most important topic for COA. In floating point representation, there are 3 parts: mantissa, base and exponent. Suppose we are given the number 9 into 10 to the power 8 and here the mantissa part is 9, the base is 10 and the exponent is 8. (110 into 2 to the power 7), mantissa part is 110 and the base part is 2 and the exponent part is 7. IEEE 754 representation. It is also called as floating point representation. There are 2 types of floating point representation. The first one is single precision format, that is in 32-bit, and the second one is double precision format, that is in 62-bit. In single precision 32-bit format, there are signed number that take 1 bit and exponent part take 8 bits and mantissa part that takes 23 bits. So from 0 to 22 is mantissa part, from 23 to 30 it is exponent part, from 30 to 31 it is signed part. So total 0 to 31, total 32 bits for single precision format. In case of double precision format, there are total 64 bits. 0 to 51 that is mantissa part, 52 to 62 that is exponent part, and 62 to 63 the 1 bit 62 to 63 is for sign part. So total 0 to 63 is for double precision format or 62-bit representation. Now represent the given number 1259.125 that is decimal number into floating point representation. The first step is you have to convert the non-fraction part, that is 1259, into the binary number, and then you have to continuously multiply the fraction part, that is 0.125 with 2 until and unless you get 1 point something, and like this you have see here, you have seen here that 0.125 into 2 is equal to 0. Again 0.25 into 2 is equal to 0. Again 0.5 into 2 is equal to 1. And then the step 3 is single precision format, that is 1 n in the base 2. E minus 127 is equal to 10. And for double precision format, that is 1 base 2 to the power e minus 1023. So here e minus 1 to 7 is equal to 10. So e is equal to 37. 137. There is another example. Here is the flow chart for multiplication of unsigned number. This is also very important for your exams, semester exams. Here take a screenshot. Now Booth's algorithm method, multiplication with respect to Booth's algorithm method. This is a very important topic. I will definitely try to make another separate detailed video of this topic. So you can take this example for now, and you can practice this in your notebook. Booth's algorithm also very important. You have to practice it with respect to signed number or unsigned number. This is the flow chart for Booth's algorithm. Restoring division algorithm for signed integer number. There are some more examples over this topic. Half adder. Full adder using 2 half adders. Ripple carry adder or binary adder. Binary adders are two types: binary ripple carry adder and binary look ahead adder. Memory hierarchy. Write through policy and write back policy. Write through policy, both cache and memory are updated with every write operation, and write back policy only cache updated and the location is marked so that it can be copied later into the memory. Memory locations. 2 to the power 10 bits is equal to 1 KB is equal to 124 bytes. 2 to the power 20 is equal to 1 megabytes is equal to 124 into 124 byte. 2 to the power 30 is equal to 1 GB or gigabyte is equal to 124 into 124 into 124 bytes. These are the some numerical type questions over construction of large memory using small memory. There are three types of mapping: direct mapping, associative mapping, and set associative mapping. Here are some numericals over set associative mapping, where you are given the memory that is 156 megabytes, and that is main memory. The main memory is given that is 256 megabytes, and the cache memory that is 1 megabyte, and block size that is 128 bytes, and 8 blocks in a cache set, 8-way set associative. You know that 1 KB is equal to 2 to the power 10 bytes, and 1 MB is equal to 2 to the power 20 bytes, and 1 GB is equal to 2 to the power 30 bytes. So here main memory contains total 28 bits, and cache memory contains total 20 bits, as well as block size contains 7 bits. You can see the process to convert megabytes or bytes into bits. Now the line number required is the cache memory divided by block size, that is 2 to the power 20 by 2 to the power 7, that is 2 to the power 13 bytes or 13 bits. Now in direct mapping and associative mapping, in this way you have to draw. Eight-way set associative is equal to 2 to the power 3, that is 3 bits, and number of lines is 13 bits. There are two types of memory. One is primary memory and second is secondary memory. And primary memory is again divided in two parts, that is RAM, random access memory, and another is ROM, read only memory. And in other case, a secondary memory is divided into two parts, that is magnetic disk and other is optical disk. RAM, there are also two types of RAM. One is SRAM, SRAM or DRAM, and ROM are divided into three parts. PROM, EROM, EPROM, and EEPROM. Now let's get learn what is PROM. That is programmable ROM, or you can say programmable read only memory, that is programmed once and contents never changed. In case of EEPROM, this is erasable programmable ROM. It is it can erase entire data and reprogrammed repeatedly, expensive than PROM. EEPROM, it is electrically erasable programmable ROM. This is erasable 1 byte at a time and more flexible but slow. Here are some circuit diagrams for SRAM and DRAM. Virtual memory. There are some disadvantages of paging. Pipelining, this is a very important concept in computer science, or you can say in COA. Pipelining is a technique in which instructions are divided into sub-instructions, with each sub-instruction being executed in a different segment. Each segment does partial processing on the instructions, and the outcome of the segment is transferred to the next segment in the pipeline. Segments can operate with other segments of the pipeline. Pipeline hazard, data hazard, structural hazard, and control or branch hazard. Pipeline hazards are the situations that prevent the instruction in the instruction stream from executing or in during its designated clock cycle. Isolated input, output, or I/O or mapped I/O. This is very important type of topics. The difference between I/O mapped I/O or memory mapped I/O. Modes of data transfer: programmed I/O, interrupt I/O, initiated I/O, DMA or direct memory access. Now, what is programmed I/O? Data transfer from I/O is to memory. Programmed I/O use handshaking technique. Direct memory access or DMA, dynamic memory allocation.